All right, let's dive straight into this explainer. Today, we're tackling what is literally one of the most frustrating bottlenecks in AI-assisted coding: context loss. If you've been using AI tools to help write, refactor, or debug software, you already know the pain of an AI that forgets everything the moment you close your terminal. Today, we're looking at a fascinating open-source infrastructure called Claude Memory that completely eradicates this amnesia. So here is our roadmap for today. We'll define the blank slate problem, meet the Claude Memory solution, explore its visual timeline, peek inside the distillation engine, and finally, look at setup and local privacy. Let's get into it.
Part 1. The blank slate problem. Picture this, because I know you've been there. You've just spent 2 hours deep in a debugging session. You're nailing down complex architecture, squashing tricky bugs left and right, and you are totally in the zone. Then you close the terminal, get some sleep, and the next morning you open a new session and boom, completely blank slate. You have to re-explain your entire stack, your preferences, and the exact bug you spent 2 hours fixing yesterday. Every session starts from absolute zero. You literally ask it, "Remember when we fixed the auth bug last week?" And it hits you with that dreaded response, "I don't have access to previous conversations." It is an absolute momentum killer. But here's the thing you have to understand. This isn't actually a problem with Claude itself. The underlying AI model is brilliant. Rather, it's a missing infrastructure problem. The persistence layer just isn't there out of the box. But the fantastic news? We can actually solve it.
Which brings us to part 2. Meet Claude Memory.
So what is it? Claude Memory is essentially exactly what it sounds like. It's a persistent vector memory system that runs completely locally, right alongside your Claude Code instance. Think of it as giving your AI a permanent, highly searchable brain. Across every single project and every single session, your AI assistant instantly recalls exactly what you worked on. Under the hood, the architecture relies on a beautifully simple stack. On one end, you have your interface, which is Claude Code. In the middle, the middleware, an MCP server spun up on port 3333. And on the other end, the database, a local PostgreSQL database supercharged with pgvector for semantic search. This server connects Claude Code directly to the database, exposing 18 different tools that Claude can call to save memories, search them by their actual meaning, and pull context. In fact, before you even type a single word in a new session, Claude uses a tool called startup_context to load up everything it needs to know.
Part 3. The visual timeline.
Now, you can actually peek into the AI's brain using a 3-tier dashboard available locally right in your browser. It builds a complete model of how you work over time. It uses 3 tiers. First, explicit preferences, things you've specifically told it to save manually. Second, signals, patterns it extracts without an LLM, like your go-to terminal commands or the files you edit the most. And third, the really fascinating one, inferred preferences, which are complex behavioral observations made by the AI itself. This inferred tier is where it gets crazy. It surfaces incredibly specific behavioral observations, just like this one here. The user prefers reviewing diffs before committing rather than using git add-a. The wild part is, you didn't write this. The system simply noticed it automatically by watching how you work. It picks up on your communication style, how you approach decisions, and your habits regarding testing and documentation. The whole shebang. Now, you might be wondering, if it's constantly saving memories, won't the database just get bloated with junk? To prevent noise, the system has a brilliant built-in deduplication check. It simply skips saving a memory if it already exists at a 92% similarity match or higher. And if a potential new memory scores between 75 and 92% similarity, Claude is smart enough to just update the existing memory rather than creating a duplicate. It keeps your vector database incredibly clean and highly relevant. All right, part 4. Inside the distillation engine. We developers generally hate black boxes, right? So looking at a system this capable, you're probably asking, how exactly does it build these complex insights without sending all your proprietary coding session data to some cloud API for processing? The answer is completely local processing. You see, raw coding sessions are incredibly verbose. If you search through raw transcripts, you're just going to get bogged down. So a local Llama model actually reads your raw sessions and distills them. It takes a messy 200-line transcript and compresses it down into about 8 crisp, highly searchable memory tags. It extracts only the durable knowledge, the decisions you made, the established patterns, and the root causes of the bugs you fixed. But it doesn't stop at just recording facts. It performs a dedicated behavioral pass to extract those durable insights we just talked about.
It ensures Claude understands your preferred coding style before your next session even begins. It analyzes how you worked, noting your correction patterns and your decision-making speed. And because the system uses semantic search, if you look for auth bug, it's going to return memories about JWT expiry issues or OAuth redirects, even if the exact phrase auth bug isn't in those distilled tags.
Moving on to part 5, setup and local privacy. You might assume a tool this powerful requires a whole weekend to configure, but the setup is completely frictionless. Just look at these 3 steps. Step 1, clone the repo. Step 2, run a quick start bash script. Step 3, just start coding with persistent context. That's it. The quick start script automatically handles Docker, registers the MCP server with Claude Code so it works in every project directory immediately, and even imports your entire existing history in one pass. It takes about 2 minutes tops. And as for maintenance, there literally isn't any. Once you install it, an optional macOS launch agent just hangs out in the background, checking in every single hour to import, distill, and update your preferences completely autonomously. Whatever you code today is automatically distilled and searchable tomorrow. And if you want to back it up, it takes a single command. And because the data is perfectly distilled, an entire history backup might only be around 2 megabytes. And for absolute ultimate peace of mind regarding your privacy and corporate security policies, exactly 0 bytes of your proprietary codebase ever leave your machine during this distillation process. The database is local, the Llama model doing the distillation is local, absolutely nothing goes to the cloud. You're getting enterprise-grade AI memory infrastructure with total data sovereignty.
The real gap between a generic, powerful assistant and a truly useful collaborative partner is persistent context. History that is automatically distilled, searchable, and a system that actually learns how you prefer to work over time. Claude Memory fills that gap perfectly. So, I'll leave you with this final question. Are you going to continue grinding away, re-explaining your entire stack to a blank slate model every single morning? Or is it time to spend 2 minutes upgrading your workflow with persistent AI memory? The choice is pretty clear. Thanks for joining me on this explainer, and happy coding!